This is a problem about solving a rational inequality. So we're given r of x is equal to x minus 2 over x squared minus 3x minus 40. So, and here's the actual problem. They want us to, this is the rational function, but here's the inequality part. R of x, let's say that they wanted us to say, when is this greater than or equal to 0? This is what we have to determine. So we want to know for what x values is this function, the y part, above the x-axis or touching the x-axis. So to do this, we use critical values. Critical values come from from x values where r of x equals to 0. So that's going to happen whenever the numerator is equal to 0, or in other words, when x minus 2 equals to 0. We solve this and we find that x equals to 2 is one of our critical values, or when r of x is undefined. Well, r of x is going to be undefined whenever we're trying to divide by 0, or whenever the denominator, x squared minus 3x minus 40 equals to 0. So we solve this equation for, we solve this equation, and we can factor this one. This will factor into x minus 8 times x plus 5. Let me make sure I did that right. AC is negative 40. We want two factors to add up to negative 3. I chose negative 8. Positive 5, negative 8 times 5 is negative 40, negative 8 plus 5 is negative 3. Since a is 1, I can factor it like this. So then I'm going to get from this that x is equal to 8 and that x is equal to negative 5. And so when we do this, now we have our three critical values. And so what we do is make our number line, or our x-axis. We label our regions. Here is x is negative 5. Here is x equals to 2. And here is x equals to 8. So there's our three critical values. And it's divided our number line into 4 regions. So we pick a test value for each of these regions. Any number to the left of negative 5 will serve. So I'm going to choose, I choose negative 10. This is what I want. In between negative 5 and 2, I will select 0. In between 2 and 8, I'm going to choose 4. And something to the right of 8, I'm going to choose positive 10. So my test points, these are what I chose. What I'm going to do is plug them into r of x. When I do this, I'm going to choose to evaluate this in factored form. So this is what I'm going to be looking at as I go through this. X minus 8, x plus 5. This is what I'm going to plug each test value into, this version. So basically what I'm interested in is the sign. So if x is negative 10, then what I would have up in the numerator is negative 10 minus 2, or a negative 12. Basically, I just want to know the sign, a negative. Negative 10 minus 8 would give me negative 18, or another negative. In this factor, negative 10 plus 5 would give me another negative. So I have a negative times a negative in the denominator, which is a positive, and one negative in the numerator, which makes this whole value a negative. So for this region of the chart, this is going to be a negative in that area. Now I go to this test value, 0. 0 minus 2 is a negative in the numerator. 0 minus 8 is a negative in the denominator. And 0 plus 5 will give me a plus. A negative over a negative is a positive, so I find out that this region is above the x-axis, or positive. When I plug in 4, I'm going to have 4 minus 2, which is positive, over 4 minus 8, which is negative, 4 plus 5, which is positive. I end up with one negative value, making this entire value negative. So that's what that region's going to be. When I plug in x is 10, 10 minus 2 is positive. In the denominator, 10 minus 8 is a positive. And over here, 10 plus 5 is a positive. And I find out that this gives me a positive value for this region. Okay, that's our chart. That is the truth. These values at x is -5, this is an important part. X equals -5 came from a critical value for r of x is undefined. So the function will never equal that. An open circle belongs right there. X equals to 2 came from where r of x would equal to 0. When the numerator is 0, this is a 0 of the function. It's defined right there. It gets a solid circle. And x equals to 8 came from the denominator, and this is an open circle right here. And that's just how things are. Now what we have to do last is say, what did they ask us to answer? And they want us to answer, when is this function greater than or equal to 0, or positive or equal to 0? And so we see that it's positive from in this area where the plus is. It's equal to 0 right here where it's hitting the x-axis, and it's positive over here. So they want us to call out all these. So first I'm going to say the answer is going to be from parentheses -5 all the way to x is 2, and we get a bracket on the 2. We had to put a parentheses on the -5 because this is undefined at x equals -5. Then we're going to union it with, we skip this negative region, we're not interested in that, but we are interested where it begins to be positive again, and that's from parentheses 8 to infinity. And so this is going to be our answer for r of x is greater than or equal to 0.